measuring elasticity. If you want to measure this, here's what we do. That's the symbol for price elasticity of demand, E of D. If you want to measure it, E of D is equal to the percentage change in quantity demanded. That's what QD is. And you're going to divide that by the percentage change in price. And I'm going to explain this. So, you want to measure elasticity. E of D is the percentage change in quantity demanded. You're going to divide that by the percentage change in price. Now, you use percentage change all the time. You're probably just not aware that you're using it. And I'm going to identify how exactly you apply it to elasticity. Is there anybody here who rides a motorcycle? Yeah? One of the fast ones that are called crotch rockets?
No. Yes.
One of those fast ones? So you're driving and you're like, what was that? You just see a little shirt all the way up. It's Jonathan, right?
Yeah.
Let's say you're on your motorcycle. And when you go on your motorcycle, you're riding, and it's on the 405 and it's empty. This will never happen. But you go on your motorcycle, 405, and it's empty. You go, all right, this is good. So what you decide to do is you decide to ride your motorcycle at 100 miles per hour. Don't do that, by the way. You're riding at 100 miles per hour. And you look around, no cops, no cars. So you're riding at 100 miles and you say, this is really good. And what you do is you increase your speed to 120 miles per hour. What's the percentage increase in your speed? So you were riding at 100 miles, and then you increase it to 120 miles. What's the percentage increase? How much?
20%.
20%. What you guys are doing in your head is percentage change. Percentage change is a very simple formula. You use it all the time. What I mean is, what you did in your head was this. New speed, you subtract the old speed, and you divided that by the old speed. That's how you calculate percentage change. You did it in your head. You took 120 miles per hour, you subtracted 100 miles per hour, and you divided it by 100 miles per hour, and that's how you got 20%. What I'm saying is, when it comes to the percentage change in quantity demanded and percentage change in price, you're going to be doing the same thing. I'm going to tell you the price of a good is $5. You then raise up the price to $6, which means you're going to have a new and an old. Because of that price increase, I'm going to tell you that that affected the quantity demanded. If you raise up the price, the quantity demanded probably moved, let's say, from 10 to 50, from 50 to 10. You're going to have a new and an old. So what you're doing in your head, you can do here. If you want the percentage change in the quantity demanded, you take the new quantity, you subtract the old quantity, and you divide that by the old quantity. And we're going to do an example. Same thing with the percentage change in price. You take the new price, you subtract the old price, and you divide that by the old price. So when it comes to percentage change, and you could calculate percentage change in anything, new minus old over old. It's the formula you need to remember. You want to calculate percentage change? Think of Jonathan on the freeway. 100 miles per hour to 120 miles per hour. New minus old over old. We'll do an example in a minute. So you're doing the same thing here, but we're doing it quantity and price. Percentage change in quantity demanded, percentage change in price. Okay? We'll do an example momentarily. Questions? Any questions? New minus old over old. It's percentage change. No. When you calculate elasticity, you're going to get a number. You need to be able to understand how to read that number. So, I'm going to show you. When you calculate this thing, you're actually going to get a number. I'm going to show you the interpretation of EMB. So how do we interpret price elasticity that we calculate? I'm going to show you. Let's start off with demand being elastic. Start with that one. When demand is elastic, what does that mean in words again? When demand is elastic.
Flexible.
Consumers are very responsive to price changes, which means when demand is elastic, change your price by a small amount, you're going to get a big reaction from the market, yes? Look at this formula again. When demand is elastic, you guys just told me, change the price by a small amount, you get an even bigger response in the quantity demanded. So when demand is elastic, change the price by a small amount, the change in the quantity demanded is huge.
Not always.
When demand is elastic, change the price by a small amount, the change in the quantity demanded is even bigger. So what I mean is when demand is elastic, you're basically saying percentage change in quantity demanded needs to be bigger or greater than. That's what that means. The percentage change in price. Consumers are very responsive to the price changes. That's what you mean. Tiny change in price, big change in quantity demanded. Let's go back to high school a little bit. You remember fractions from high school? These? Yeah? That's a fraction. Something over something. A numerator and a denominator. Now let's think about this for a minute. When demand is elastic, tiny change in price produces big change in the quantity demanded. When demand is elastic, the top of this thing is always bigger than the bottom of this thing. That's when demand is elastic. You want to visualize it? Demand is elastic, the top is always bigger than the bottom. Demand is elastic, the top is always bigger than the bottom. Demand is elastic, the top is always bigger than the bottom. When demand is elastic, what do you notice about the number?
Over 100%.
What's that?
Greater than 1.
It's always greater than 1. Whenever you calculate price elasticity and it comes out to be a number bigger than 1, immediately you download, it has to mean that demand is elastic. So you calculate price elasticity, it comes out to be a number bigger than 1, you know that's saying the top of this thing is bigger than the bottom. And if that is the case, we're saying the percentage change in quantity demanded is greater than the percentage change in price. That happens when demand is elastic. You calculate it, it comes out to be bigger than 1, you know that demand is elastic. In words, what does it mean when we say demand is inelastic? What does that mean in words? Consumers are not very responsive to price changes. That's Jason not being excited about the salt. Not very responsive to price changes. Big change in price, tiny change in quantity demanded. The salt was 50% off and he said he would probably buy 1 more. Inelastic, huge change in price, expect a tiny change in the quantity demanded. Demand is inelastic, this is big, percentage change in price, but the corresponding percentage change in quantity demanded is small. So when demand is inelastic, we're basically saying the percentage change in quantity demanded is now less than, smaller than the percentage change in price. So the percentage change in quantity demanded is now smaller than the percentage change in price. think of your fraction again. Now we're saying the top is smaller than the bottom. The top is smaller than the bottom. Top smaller than the bottom. What can we say about the entire E of D when demand is inelastic? It's gonna be smaller than 1, less than 1. Whenever you calculate price elasticity and it comes out to be a number smaller than 1, you know that same demand is inelastic, not very responsive to price changes. Why? Because if it's smaller than 1, it's saying the percentage change in quantity demanded is smaller than the percentage change in price. Questions? Should be a natural question that pops up.
What if there is one?
What if it's equal to 1? Very
There was no
good.
change, right? Then there was no change.
It's a special case called unit elasticity. This is when E of D equal to 1. Unit elasticity. And this is just basically saying the percentage change quantity demanded exactly equal to the percentage change in price. Quantity demanded is exactly equal to the percentage change in price. Special case called unit elasticity. Now let's backtrack a little. You want to figure out the sensitivity of consumers to price changes or the responsiveness of consumers to price changes. You do that with price elasticity of demand. You measure it by the percentage change in quantity demanded divided by the percentage change in price. If you calculate price elasticity and it comes out to be greater than 1, you know demand is elastic. You calculate price elasticity and it comes out to be less than 1, and you know demand is inelastic. If it's equal to 1, unit elasticity. Now before we do the example, something very important I gotta show you. Can you remind me of the law of demand again? What's that?
Price goes up, quantity demand goes down.
Price goes up, quantity demanded goes down, or the other way around. Look at this formula again. You just told me that the law of demand says these things will always be moving in opposite directions, yes? You said when the price goes up, percentage change in price goes up, quantity demanded will be going down. Or the other way around. When the price goes down, so this bottom thing is going down, it necessarily means that this top thing is going up. Because of the law of demand, we know these two things will always be moving in the opposite direction. If the bottom is going up, the top has to be going down. The bottom is going down, the top has to be going up. That's the law of demand. Which means, if these two things are always moving in the opposite direction, we know something about the sign of this thing. If this is always going up and this is always going down, or the other way around, very important, I'll put it in hot pink. Since those things will always be moving in opposite direction, what that means is E of D is always negative. The law of demand says these two things will always be moving in the opposite direction. When you calculate that whole thing, it will always have a negative sign. In this class, we're going to choose to ignore the negative sign. We don't have to write it. The law of demand tells us it will always be negative. So we will choose to just ignore it. We're not going to write it because we know the law of demand says that and that will be moving in the opposite direction. So we'll just ignore it. Okay? Let's do an example. Let's put all of this together and do an example. Questions before we get into the example? Yes?
Is the slope of the demand line elasticity?
Inverse of the slope actually, or the log of the inverse or something like that.
Okay.
questions?
It says ignore the negative sign. Is the negative sign a part of the measurement that we'll see? Is that why we're ignoring it?
We just won't write it. What they call take the absolute value.
I see.
We just write it without the negative sign.
I see.
So does elastic only happen when the price of a good goes down?
Elastic?
Yeah.
No. It could happen when it goes up or down. You could be very responsive when the price goes up or very responsive when the price goes down. Any other questions before we do the example? All right, let's do it. Let's do an example. Take this off. There we go. All right. Here's the example. Simple. Let's say for some good, let's call it X. Whatever this good is, it doesn't matter. So let's say for good X, price increases from, let's say, $2 to $5. So let's say for some good X, price went up from $2 to $5. So it got more expensive. So, because of this, the quantity demanded fell from, let's say, 15 to 10. Somebody was shouting out elasticity. You actually have to calculate it. Yeah? So you actually have to calculate the elasticity, which is what we're going to be doing. We're going to calculate E of D. We want to figure out along that price change what's the elasticity. We're going to calculate it with our formula and all the stuff we have gone through. Now I like to write my formulas again. Helps it to stick. So if I want E of D, I know E of D is equal to the percentage change. Get used to this little triangle. We use it a lot in this course. It's delta, it means change. Percentage change. Quantity demanded, we're going to divide that by the percentage change in price. That's my formula. I like to write my formula down. It minimizes my chances of errors. Now we know how to find percentage change. We think of Jonathan and his motorcycle. So let's take the top part first. We want percentage change in quantity. If you remember, what's the formula for percentage change again? How do we get percentage change? U minus old over old. So, we know this is new quantity. We're going to subtract the old quantity, and we're going to divide that by the old quantity. Let's look at our question. Where it's coming from is the old. Where it's going to is the new. So you can look at your question and figure out what's old and what's new. Where it's coming from is the old, and where it's going to is the new. So what's the new quantity?
10.
Everybody sees that? And the new quantity is 10? Is there anybody lost and not sure why we chose 10 as the new quantity? So from 15 to 10, that's the top part. Any questions? Yeah? New minus old over old. There we go. Let's do the bottom. I want to figure out percentage change in price. I know what to go to. It's new price minus the old price And we're gonna divide that by the old price. What's the new price?
Five.
Everybody sees that? That the new price is $5? We got the top, we got the bottom. If you want E of D, you got the top, and you need to divide that by the bottom. Yes? Is demand elastic or inelastic? Why? Comes out to be less than 1, so we know it's inelastic. New minus old over old. You remember that? You can't go wrong.